Am I visible? Okay, great. Uh, Actually, I thought I was a little down in the list. I was gladly sitting way back in there. Anyway, since morning we've been hearing a lot about batteries, battery storage, battery cells, and we've also been hearing about the energy transition. So I'll actually start off with one energy transition that actually happened over a century ago. And come on, man, work. Okay. Yeah, so I'm talking about the rise of the first automobiles, which started at the beginning of the 20th century. And in a matter of a little over a decade, the incumbent was hardly seen on the streets. Now, what actually drove this transition? So the most important thing is, there needs to be a great solution, a great product, convenience, but it needs to be available at very, very large scales to actually make a difference to the society at large. So coming back to batteries, what ails the batteries of today? Of course, we have been talking about great technologies, better performance, and for the past decade and a half, we have been listening to people saying that, okay, this battery is going to change the world. But the one thing that has actually been missing is it's not been available at scale. A lot of things actually work great at a laboratory level, but the transition to the actual technology is what's missing. And that's where we look to make a difference. So introducing us, we are Eternal Energy. We are actually reimagining battery cell and battery cell manufacturing in a way that completely changes performance, but also improves manufacturing. So yeah, we reimagine cell design, and most people think in cell design, it's actually the physical design, but it actually goes way beyond that. So the design itself, we went from the traditional cell architectures to a very unique three-dimensional architecture. It's based on the honeycomb, it's a natural design. And what it does is it actually changes the way the current actually flows through the battery. So this is chemistry-agnostic. This can apply to every chemistry out there. And what it does is it actually ensures that the battery does not heat up, which means that the performance automatically improves, life improves. We can charge it faster, we can charge it very safely. Talking about safety, we actually designed for safety additionally. So what we did is we made a change to the materials where the traditional separators used in the battery, which are polymer membranes, which shrink upon application of heat. Instead, we went for an all-ceramic separator, one that ensures that it's stable to temperature, heat, fire, chemicals, mechanical damage, and ensures that no matter what happens, the battery should not explode. But then, these were design side of things, right? So we actually designed for manufacturing, wherein we went with a completely vertically integrated stack, all the way from machine design to process design. From the traditional cell manufacturing process, which has about 32 operations, we created our own process, which has just 8. And these 8 require very, very small, compact machines, which we developed ourselves. Today, we have an entire lab line, which is fully automated machines and can actually build cells in a very fraction of a time and cost. About 6 months from now, we should have a fully vertically integrated and fully automated modular structure, one that can actually be scaled up for manufacturing. And talking about scalability again, right? So the advantage of this is that not only do we reduce the space that is required, not only do we reduce the cost that is required, the CAPEX or the OPEX, but also the fact that it's modular, which means that we do not necessarily have to start off with gigafactories, which require a huge amount of capital. That's where the entry barrier comes in. We can actually start small and keep adding capacity with modules over time. So, apart from the previous slides, I think this one only has 3 bullet points. But I'm sure that by 6 months, we should actually have a live demonstration
30 seconds.
working. Thank you. I'll drop that.
No, you can. Okay. Any questions from the jury? Apoorv, so one of the main challenges in gigafactories when they set up is the yield. So how do you how much yield it improves, and can you explain the
Sure.
advantages?
So one of the biggest challenges in scaling of the technology is that with the scale, if the volume changes, a lot of times the technology needs to be reworked and re-optimized. With the modular manufacturing technology, what we do is if it works on one module, a gigafactory is just going to be hundreds of modules. So if it works on the first one, you start getting the same yield from the rest of the modules. And one module is something that we can actually optimize for in lab right now.
So what's the yield roughly, if you can?
It's we still not reached the point where we can actually talk about manufacturing yield yet.
I understand.
But so the advantage over here is that there's just 8 steps as opposed to 32 steps in the traditional process. And even if we are talking about 99.9% efficiency on the steps, you can actually say that the yield comes down to a best of 95% across the traditional manufacturing step. Something over here we should be able to get a lot more than that simply because of the simplicity of the process.
Okay.
What's your IP? Do you have patents? What's your IP?
Yeah, so we have filed 8 patents so far. So the patents range across design of machines as well as processes, the materials engineering that goes in, as well as the cell design and the cell format.
And are there any non-patented trade secrets?
There are certain processes, and so the finesse part of the process, the process parameters, that itself is not patented. Those would be trade secrets.
One quick question. How long have you guys been working on this entire, from the start of the ideation point to reach this point?
From ideation, about 4 years. But from the practical, from the first machine that we built, about 2.5 years.
Thank you.
What was the capacity that you have proven so far in terms of the modules?
So we have a lab line, and the lab line can actually generate about a cell every 1.5 minutes. Of course, these are small cells, so in terms of watt hours or megawatt hours, this is a really small capacity. But the moment we actually scale to a reasonable cell, the target cell that we have in mind right now, we should be able to deliver about 15 megawatt hours in the first module and 108 megawatt hours in the second module.
Last 2 questions.
Yeah, Apoorv, maybe you can tell us about the stage around the testing. You must have done the testing right now. You're ready for scale up. So what were some of the specification related results that you've seen? So
we are currently developing the first product right now. So the process and the manufacturing machinery and equipment, that has been stabilized completely. We are in the development of the first process where some of the cells have actually run past, I think, 500 odd cycles. So the testing phase is something that takes a little long, so that we have to test it for life cycles entirely. But I think by the end of this year, or maybe the first quarter of the next year, we should have the product ready.
Thank you.